seminar from the University of Washington eScience Institute. It is my pleasure to host today Julia Ferraioli, who is an open source engineer, scientist, and analyst with a decade of experience in launching, managing, and optimizing open source projects at scale. She currently works at AWS as the AI ML open source strategist, providing guidance and expertise in the open source machine learning field. Additionally, Julia is a co-founder of Open Source Stories, contributor to LeadDev, and open source sustainability researcher. Her background includes research in machine learning, robotics, human-computer interaction, and accessibility. And actually, I met Julia at the eScience Institute last year, where she delivered a talk for the eScience staff, and I really enjoyed her talk. And I know many of you are developing open source codes for your research. Sometimes it just ends up as a GitHub repository. Sometimes it will evolve into a bigger package embraced by a larger community. So I thought that Julia would provide useful insights about how to maintain, engage, and continue beyond your little GitHub repo. Thank you, Julia.
Thank you. Move the mic over here. Hopefully that doesn't screw things up on Zoom.
I don't think so.
Okay, cool.
Should be fine.
Cool. Hi, everyone. How's it going? Is this the end of your day or the beginning of a study session? Why not both? Okay, cool. So thank you for the kind introduction. I am here to get on my soapbox, which is metrics in open source. It's a soapbox I've been on for years now, and I'm excited to share with you some of the best practices that I've found when establishing metrics for open source projects, as well as avoiding some classic pitfalls that arise and that we've seen affect the success or failure of open source. So I know that I saw some heads nodding. Who here currently contributes to an open source project? Okay. Who here runs an open source project? Okay. Who here wants to know more about open source? Okay, cool. So I'll give a little bit of overview about what it actually means to be open source. It's not as straightforward as people kind of like to think. And then we'll dig into some grounding about how open source ecosystems actually work. I think there's time for questions at the end too, maybe?
Yep.
Okay. So there is an actual formal definition of what it means to be open source. And this is stewarded by the Open Source Initiative. It was created or established in 1998, so it's quite a mature definition at this point. And it talks about the rights and responsibilities that people have when creating open source and using open source. And at the heart are the 4 freedoms: the freedom to see, the freedom to use, to modify, and distribute code. And that's very code-centric, but it was the easiest way at the time to really protect open collaboration that had been the norm, primarily in academia, before code was elevated to the point of a creative work in the eyes of copyright. So in the 70s, there was actually a ruling, actually I think that might have been the early 80s, now I'm thinking about it. There was actually a ruling that said how you implement things in code is equivalent to a novel. And so that's how we came to have proprietary software. And the establishment of the open source definition was really to push back against that limitation. So these rights and freedoms, or these freedoms and responsibilities, were codified into this open source definition and implemented using open source licenses. This is not a license talk, so I'm not going to give you the ins and outs of MIT versus Apache versus BSD. I am not a lawyer, and I'm not pretending to be one. But the history of open source is actually really fascinating from a political, a sociological, and a technical standpoint. So that's a whole different talk, though. One of the key parts about open source, though, is, and this is in the open source definition, you can't discriminate on the basis of who you are or who the other person is, what they're doing with the code, and what industry they are in. And that's really important when it comes to preserving the longevity and sustainability of open source as an entire ecosystem. Because as soon as we get into, well, I'm going to carve out an exception for you or you or you, then the thing kind of crumbles, unfortunately. So, okay, that's the background of the technical definition of open source. There is an annotated version. If you go to the opensource.org/OSD, you can find a more full explanation of what it actually boils down to. But that's not actually what people tend to mean when they say open source. There's a joke in pretty much every industry that if you ask N open source experts what open source is, you'll get N+1 answers. I actually have maybe like 5 or 6, but that's I'm just skewing that statistic. When people engaging in open source activities or open source ecosystems use the phrase open source, they're rarely referring to that technical definition that we just went over. They're talking about more than just the minimum bar of what it means. It's evolved to represent a very complex framework that shapes how software is created, released, shared, used, distributed, as well as the communities themselves and how they form around projects. Additionally, depending on what lens you use to examine these frameworks, you can determine different types of interaction of and between open source ecosystems and communities. So we'll have a very brief introduction to software as a complex system. So if we consider each of these lovely shapes to be open source projects, you might have different types of projects. Some might be libraries, some might be SDKs, some might be web frameworks. You could go on and on listing all the types of open source projects that exist out there. But what's important to know about them being in this open source space is that they have components, these components on the screen, that interact in multiple ways, following local rules, with no unifying rule to define all interactions. And the emergent system is greater than the sum of its parts. I always wonder what happens when I click that button, and the answer is nothing. Okay, Now, in software, we have other elements of complex systems, which are people. And that means that things get infinitely more complex because people are ridiculously complicated. So what this winds up being is a socio-technical system. And because we are involving people, not only are things more complicated, we have two additional constraints to really consider when evaluating them. The first is that you can't separate out the social and technical aspects of an organization because they are inextricably linked. And this is really uncomfortable to a lot of people who think of open source or software as being just code. The second is that we have to account for the interactions between our society's complex structures and the behaviors of the people who live within them. You'll hear a lot when engaging in open source that it has no borders. There are no boundaries. But actually, there still are, because we are still subject to time zones, for instance. How do they work? I don't know. Someone tell me. As well as things like local regulations. The United States has something called export controls, which does apply to open source software, which means that you can't export something to certain countries. So the socio-technical system applies to both software and open source software, because open source is they're not just technical projects. It's the combination of the technical and the social. And it's even more so in open source than in proprietary software development, because, well, at the end of the day, you're relying on goodwill and volunteer effort. And if you treat a volunteer poorly, they're not going to come back. So humans are a critical part of the open source ecosystem. So when we are looking at open source and open source metrics, we have to consider things like infrastructure, code, packaging indices, metadata, and more. But we also need to consider the people, communities, their governance, their social contracts that they establish amongst themselves. And of course, how those all intertwine and interact. So this is really why measuring open source is difficult. There are lots of references out there that say open source is critical to business. And I believe that to be true. The research is very spotty and incomplete. So we don't have hard data about that particular statistic. And I can show that. And it's because nobody really wants to disclose what open source projects they're using. It's a security risk for companies. So in Roads and Bridges, Nadia Eghbal's paper, she outlined this problem, saying that usage metrics are either highly inaccurate or simply absent. It's not an easy problem to solve for. But without data about which tools are used and how much we rely upon them, it's hard to paint a clear picture of what is underfunded. And the corollary there is it's also hard to paint a picture of what is overfunded. And when we talk about funding, it's time, talent, and treasure. It's not just money. And it is very easy for resources to go to a particular project from a bunch of different avenues, from individual sponsors to individual contributors to corporate sponsors and contributors. And it's hard to recognize when something is actually taking away from another project's resources. She continues that with better metrics, we could do things like describe the economic impact of open source on digital infrastructure, identify critical projects that are lacking support, and understand the dependencies between projects and people. So let's talk about how to define better, more meaningful metrics in the context of open source, in the context of this ridiculously complex socio-technical system. Better metrics focus on useful metrics. I think, did anyone catch this week's XKCD? Do people read XKCD? I feel old. Okay, cool. XKCD is a webcomic. It's very nerdy. And I believe the theme of this week's was don't let your metrics become a target. And that is something that happens a lot in open source and isn't generally a problem unless you have bad metrics, unless you've established bad metrics. So the first thing you really want to do is establish objectives, then define their observable aspects, establish your baselines, figure out your trend, and determine your signal phenomena. So we're going to go through this step by step. So it's very tempting to determine what you can measure first when thinking about metrics. And this approach can lead to an abundance of data collected, but it can also lead to very misleading metrics. Instead, you need to first identify your objectives. You need to know what you want, and you need to know what you care about. If you can't answer both of those questions, then you need to go back to the drawing board. The objectives that you set for your open source project aren't set in stone. They can be anything from like, I want more adoption to I want a healthy, vibrant community. And then you have to define what all of that really means, but we'll get to that. But those objectives can change as the needs and roadmap of your project changes. So just because data is there doesn't mean it's useful. Storage is cheap now. Computing is cheap now. That leads to us collecting a lot of data, but it's not all data that can be used in any meaningful way. So then we define the observable aspects of our objectives. So you need to understand what you want actually works. And another way to really determine that is to think about these things like traits. What does this objective exhibit when I'm looking at it? And choosing the aspects of your metrics is a really important step. And it's important then to go back and remind yourself that you shouldn't limit yourself to what data is there. And you shouldn't constrain your traits to what data is there. So sometimes what you want to measure doesn't match up to data that you can actually collect. And in that case, we can use things like proxy variables to get close to what we want to actually figure out. Metrics are kind of meaningless if you don't know where you're starting from. So you need to establish a baseline for each of those aspects. And you need to know where you are now so you can make an informed estimate and you can do that in a few ways. One is to look at other projects and to see where they are as an analytical starting point, measure for a short bit of time, and then reestablish your baseline. The fourth, define your desired trend. it's not always increasing that you want. There's a very large tendency in open source to say, the more pull requests, the better. Actually, that might be an indicator that you're massively screwing up. And the last step is defining your signal phenomena. And this determines when a change will appear in an observation. So does your aspect capture events before the impact shows in other metrics? Then it's a leading signal. If it's after, it's a lagging signal. And these steps might seem very straightforward, and that's the point. This isn't a complex process. This is very, very straightforward. But we want to get from this point of saying, what can we measure, to what should we measure? What do we actually want to know? And that's a step that a lot of open source projects miss when establishing metrics. So the process isn't foolproof. It can fall short if it fails to consider the boundaries of the system that it models. If we limit ourselves to the code, we're ignoring the impact of and on the community, the surrounding ecosystem. We have to reset the boundaries and our metrics process to include both the projects and their communities, factoring in the socio-technical system. So when establishing metrics, we have to expand our abstraction level beyond algorithmic framing. When we talk about algorithmic framing, we'll be using the definition from the paper published in 2019, Fairness and Abstraction in Socio-Technical Systems. There will be a link at the end. I highly recommend checking this out. It's a very good paper. So they define algorithmic framing as choosing representations of data and labeling of outcomes. Who here has some experience with machine learning? That's very different than when I went to school. Okay, cool. So in machine learning, these choices are then used to compare outputs to inputs. It's standard for most data analysis, where methods are chosen based on inputs and then compared to previous outputs. We can apply a similar methodology to open source metrics and analysis. The problem that we encounter, though, is when examining socio-technical systems, it creates too narrow a view. And I quote, where the abstraction is taken as a given and is rarely, if ever, interrogated for validity, despite the fact that many of these choices are made due to accidents of opportunity and access to data. What data do we have? Not what data do we need? As the authors frame, the contrast to the algorithmic frame is a socio-technical frame, which explicitly recognizes the models and analyses as part of the socio-technical system. We can get there by first understanding what kinds of problems these limited abstractions create, what this work defines as an abstraction trap, and how to mitigate them. So we'll take a look at them. But first, we're going to establish a very ill-defined objective, because this is a made-up problem and a made-up project. So we want to make sure that it's easy and straightforward to install our open source Python library. No more detail than that. That's all we've got time for. No, I'm just kidding. So our first abstraction trap where we get into trouble is something called the framing trap. And this is when we fail to model an entire system over which a social criteria will be enforced. So let's propose something. 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 Let's propose someth let's track the number of issues reported around installation of our library. Well, we quickly run into the framing trap because, first of all, a lack of reported issues doesn't mean that people don't encounter them. If their first experience with your library is that they can't install it, they're going to move on. But the other one is the likelihood of actually reporting issues vary. And this is something that we see outside of open source as well. If the problem isn't big enough or doesn't cause you enough distress, then you're just going to put up with it and move on. But additionally, we're failing to model the entire system. And what do we need to do? We need to probe deeper. What gets in the way of reporting issues? Do people have the information that they need to create a quality issue report? Do they have to create an account to file that issue? Are you providing them good guidance about how to collect the information that you want in order to debug their issue? So if we simultaneously factor in the technical components, the issue, and the social components, the issues with reporting issues, then we can get towards a better frame for this particular objective. And that includes, like, who are we including and who are we excluding from our frame of reference? Are we making those choices deliberately, or are they just accidental? When we examine the socio-technical side of the data, we can also query whether our underlying assumptions about who our users are faulty. Our second portability trap, or our second abstraction trap, is the portability trap. And this is where we apply one situation to another and it doesn't really fit. Our proposal. It's a new library. We're going to, we don't have any existing data. So I'm going to look at a JavaScript library and see how they are with their installation process to see where I should be or where I should be going. This is problematic because the profile of a JavaScript developer is very different from a Python developer. How they use tech differs. Their background differs. Their community differs. Their entire, kind of actually just the end-to-end experience differs. So comparing yourself using a JavaScript library as your baseline is going to lead you down the merry path of pain. And I don't want that for anyone. What assumptions are we making about our users? Well, we need to determine, okay, well, are we making assumptions about the domain? We need to compare like to like. We need to compare what type of Python library we are to another similar type of Python library. You can't compare a data science library to a web framework. It's meaningless, but yet we see people doing it. So if you can't find a good analog, then you start from zero, and that's okay. The formalism trap is fun as well. It's when we fail to account for the full meaning of social concepts, which can be procedural, contextual, and contestable, and can't be resolved through mathematical formalisms. People really dislike this one because everyone wants things to be solved with math. Right? Just me. Okay. So proposal. Use your machine as the maintainer of this open source library to record and evaluate installation times. Well, the problem is it makes the assumption that everyone has the same resources that you do, that they're working on the same type of machine, same type of operating system, same hardware specs, etc. And that's just not accurate. You might be able to evaluate regressions for your particular architecture, but not necessarily for everyone else's. So you have to probe a little bit deeper. Think about what types of environments the library is likely to be installed. What tasks are people using the library for, and how do they impact what is on the machine? Interactions between the Python environment. Maybe they have multiple Python environments installed. I still don't really understand how Conda works. I know that it's magic, but I know that it does impact how well things run or how performant they are. The ripple effect trap is one that's especially important in socio-technical systems. And this is when we don't recognize that don't understand how the insertion of technology into an existing system changes the behaviors and embedded values of a pre-existing system. That's a lot of words. What does that mean? Well, let's go back to our objective. We want to make sure that we want our library to be easy to install. And so one of the ways that we can do this is trying to gather qualitative data.
Somehow the Zoom
No, not working.
is not advancing the
Oh,
slides, but
okay.
I think you can continue. And
Okay. Yeah. Let's develop a tool that automatically emails everybody who creates a fork of your open source project, asking them for feedback. I mean, most people on GitHub have at least one public email. This is a doable thing that we can actually script up, probably in an hour or two, depending if you're using Perl or not. So that actually might make people very reluctant to both fork and contribute to your project. That violates the social norms of open source. And so you may actually, if you implemented this type of automation into your system to get the metric, you might actually be tanking your own project. So you have to ask yourself, what in the community that I'm in, what are the norms that I have to follow? And what acceptable approaches are there for reaching out to users to get this feedback? Our final abstraction trap is the solutionism trap. And this is one technology is very good at. It's when we fail to recognize the possibility that the best solution may not involve technology. Quantitative data is awesome. I love it. It's great. Clean numbers make me happy. Not having to clean the numbers makes me even happier. So what better way to get the data that we need around people's experiences and issues with installing our library than to embed telemetry? So you don't have to reach out to people. You can silently observe them from afar. And that way, if the installation fails, you get a report and you never have to ask them for anything. Lowers the burden on you and them. It sounds great, but this leads us directly into the solutionism trap. This is 100% against open source norms. No one is going to use an open source project that phones home. It will also probably lead you down the merry path of contextless data, because you don't know how the person is interacting with the system. You only know what the system is telling you. It overlaps a little bit with the ripple effect trap, because this will probably lead to people forking your library, ripping out the telemetry, and splitting your community. And then people will abandon your project and then go use the one without telemetry, which is absolutely their right as an open source project. It's kind of hard to stop enumerating those problems. Don't just say no to telemetry. Nobody likes it. So we have to ask, is this okay? Is this a thing that people will put up with? And I urge you not to establish practices that people have to put up with, but ones that they will instead enthusiastically participate in and embrace. So you have to invest in your communities and adopters instead of simply viewing them as a source of data. Develop bidirectional relationships with both your contributors and the people who use your library. You have to ask them open-ended questions, going back to that qualitative data, and learn from their experiences, because how they interact with your technology should influence where you take it next. So remember that the metrics you choose are a reflection of what matters to you, your project, and your community. We went from very, very simple steps to very nuanced concepts about what to avoid. It takes work. Establishing good metrics in open source takes work. But if we take into account the technical elements and the social elements and how they interact and behave together, we can try to avoid these abstraction traps and paint a much more complete picture that helps projects achieve the goals that they actually want, instead of copy pasting something from one project to another. So if your goal is not just to release software, but actually foster and nurture the community and the open source ecosystem that we all use every single day, then the extra work, I promise, is worth it. So some references. So this is the Roads and Bridges report, a link to the fairness and abstraction paper. If you're interested more in how to use open source data in research, then that third one is a paper that myself, Amanda Kiseri, and Dr. Juniper Lovato authored around best practices for research in open source ecosystems. The photos you saw are from Unsplash and the icons from Font Awesome, because attributing work is how we do it in open source. So I went fast because y'all are intimidating, and it's very, like, even just the steepness of the hall is like, whoa, makes it seem much more formal than I am normally used to, which is like in a conference room somewhere that's poorly lit. So thank you. You can find me various places. I'm easily findable. There's only one Julia Ferraioli in the entire world. So thank you, parents, for my last name. And I am happy to answer some questions if you have any.
Thank you so much, Julia.
Sorry about the.
No, that's okay. We'll figure things out. I'm pretty sure you'll have questions for Julia
Maybe.
now that you know what it takes to go beyond and the
Code.
GitHub repo, yeah, and build a community and establish your metrics. Like, for example, what was the most difficult thing to do in your experience?
I mean, so
There were many.
yeah, yeah. One of the things that that we see a lot in open source projects is people falling into that portability trap. They see a project that they perceive as being successful. And so what they do is they not only port over the goals, the objectives, and the metrics, but they port over the behaviors, the governance, the norms, and not realizing that sometimes, well, maybe you don't want maybe you don't want SciPy to look like Kubernetes. They're fundamentally different things. They have fundamentally different engagement strategies for what their contributors should be doing and what they view as success. So that's the one that we see most often. And it's so tempting because the work is already done. And it's open source. So as long as you attribute it, you can use it. But oftentimes this leads to suboptimal results because guess what? Your goals are not their goals and your developer is not their developer. So you have to really think about establishing your own, and people like to learn from others. And in some cases that creeps into just porting from others.
I don't know if this is even something that you could tell from the outside looking in, but do you have any projects come to mind for you of like groups that have done this well, I suppose?
Oh, that's a good question. So,
Or is it something that you can only really tell if you were the person that's like?
yeah, I think it's more the latter because unless they've publicized their goals, and oftentimes projects don't, not because they don't want to, but because they haven't put it down on paper. They just have it in the back of their minds. But you know what? Actually, one that I think has done pretty well is, does anybody here use Z Shell? So some people do. There's a plugin for Z Shell called Oh My ZSH. And they set up really good goals at the outset. I'm not sure that they were very deliberate about doing so, but they were able to use those goals and the metrics that they implemented to track them to stay true to what they actually wanted to do. So one of the things that is nice about well-implemented metrics is that you can use them to push back against things that will take you off your intended course and help you prioritize and focus. And when in open source, the person doing most of the lifting is probably wearing multiple hats. So focus is very much needed. Yeah, I would like people to be more deliberate and think about these things more at the outset, but we're not there yet. So, yeah.
So I've read like sort of niche engineering calculations, and I try to do them enough to be transparent. But when do I cross the threshold into like I'm being transparent to like, this should be following open source best practices and, supporting.
That's really up to you. Like, the thing is that while we have different ideas of what open source means, as long as you're clear about what you want, what your goals are, and what you want out of the project, then you can just kind of keep it as is. If you want collaborators, though, that's the point at which you might want to think about putting a license on it, and trying to build a community. And that, I guess there is kind of that tipping point, but you don't have to. It's the great thing about open source. You can be a sole maintainer until the end of your days if you want to, and that's perfectly okay. So, metrics are hard. People are difficult.
So what do you recommend, Julia, for like a sole maintainer who wants to bootstrap up to be using some of these best practices and some of these metrics so that they can, not just because we like to learn from other people, but because other people, they've gone some way to a solution that's useful for us. So how can we do that without falling into these traps?
Well, I think the most important thing is the framing within your own head. There are so many great, powerful tools out there that will help you measure things with respect to your open source project. The key is to recognize them as tools and not the end. So I think starting with a couple of basic goals and figuring out how you want to see them exhibited in your community, that's really the basic starting point. They also may be time sensitive. You might not want to invite a bunch of contributors until you reach some undefined point, where you've got stability or you have bandwidth for actually doing code reviews. So I would say don't try to implement all of the metrics yourself, but also be very mindful and conscientious about which ones you choose. And please do not use GitHub stars. That's that's the only takeaway. Don't use GitHub stars as a metric. Some good resources.
Isabel, yes.
Wow, they really make that jarring, don't they? Oh, man, when I was in school, we didn't have bells. Wow, okay. There are some good tools out there. The Chaos project, which is a project under the Linux Foundation, it's CHAOSS, with that extra S on the end. It's a project that's run by data scientists to help you do some measurement for your open source project. It's a little, it is opinionated. And so you may want to evaluate what goals their measurements might fit, but that's kind of going backwards in the process. So yeah. There's no substitute for hard work, unfortunately.
All right, thank you, Julia. That's food for thought. I know that you're building your careers, and in the future, data science products may be part of your portfolio. So as you are advancing your careers, please keep in mind these things and be happy.